Good afternoon, everyone, and thank you, Per Espen, for inviting me. So I'm from Fortum Oslo Varme, and I will be talking about our carbon capture project that we are working on. And as Per Espen said, if you remember the big blue part of the pole of Oslo's emissions, that's from the waste incineration at Klemetsrud, and that's what we're aiming to do something about with this project. First, a little bit about who we are. So our company is a district heating company where the main source for heating into the district heating system is the waste incineration. We also have other heating sources, but waste is the main heating source. So basically, our main operations are the district heating system, but also the waste handling, because we need a sustainable way to treat sorted residual waste that we really can't recycle and reuse. We have two different owners. Fortum is one of our owners, an international energy company focusing on production of power and heat. And they operate in Scandinavia, the Baltics, and also quite big in Russia. And we're also building up in sun power in Asia. And then our other owner is the city of Oslo, with, as you now know, quite ambitious climate goals. And Oslo has been very clear that in order to reach the climate goals, we have to be able to realize this CCS project at Klemetsrud. And for that, we are dependent on the government to reach the right decisions. Of course, waste is also a big part of the city. I mean, the waste management in a city is a big part of the infrastructure and good and sustainable city solutions. So that's also a big part of our cooperation. So about the project, this project is a state project where the goal is to establish a full value chain with capture, transport, and then permanent storage of CO2 below the seabed in the North Sea. The aim for the government is not only to reduce, it's actually not to reduce the climate emissions. That's not the main goals. The main goal is to establish a value chain that is possible for other emission sources all over Europe to connect to. So we have two capture projects, is our project at Klemetsrud, and then another capture project from cement production in Brevik. So we are competing about being a part of this full-scale project. So that's the aim is not really to handle those emissions from these two industries, but it's to establish a solution for all, or at least a lot of the industrial emissions all over Europe. We have the geological formations in the North Sea that is very suitable for storage of CO2. And we have the competence with the oil and gas business. And here you can see the interface between the capture projects and then the transport and storage part, which is run by a cooperation between Equinor, Statoil, no, excuse me, former Statoil, Equinor, Shell, and Total. So they will be handling the CO2 from port, where we deliver the CO2, and then they will transport the CO2 by ship to an intermediate storage at the western coast of Norway. And from there, the CO2 will be pumped via pipeline to a permanent storage place in a geological formation in the North Sea. So that's the whole project, and it's of course quite a large investment for the Norwegian government, which means that they are very focused on expenses, and they're also very focused that we can actually prove that we will be able to move the business, and we will be able to point at the next projects to come who will want to connect to this storage part. So a little bit more about our project at Klemetsrud. We are, as I said, incinerating sorted residual waste that we really cannot recycle in any way. We aim to capture about 400,000 tons of CO2, which is about 90% of our total emissions. And then we are planning to transport the CO2 by electrical trucks, because we're not situated at port. So we need to find a way to transport the CO2 from our plant and to port. And we have, of course, looked into pipeline, but it proves to be quite difficult and also quite expensive. So the main solution for now is trucks. We have chosen a technology supplier which has built a full-scale plant in Canada from coal power. So, and they have had a lot of trouble with that plant. Lots of issues and lots of hang-ups. And of course, the plan is to learn from their experience, because that was the first time, and to not do the same mistakes again at our plant. And the same way, we want to transfer our learning from our project to the next projects to come, so that we can build in the future cheaper, more effective, and with a less footprint for the next plants. We are connected to the district heating grid, which means that we can reuse the heat from the capture process. And we're also, one special thing about the waste industry is that we're about 50% of the waste that we are treating at Klemetsrud or at similar plants is that it's 50% biomass, which means that the CO2 that we are emitting is also 50% biogenic CO2, part of the natural CO2 cycle. So when we capture that biological CO2, we actually go CO2 negative, or as Per Espen likes to call it, climate positive. Yes. And that's what we know, that we also need to capture the biological CO2 in order to reach these ambitious climate goals that we have for to reduce the global warming. So why are we focusing on waste as one of the two industries that we are looking into in this full-scale project? Well, it's because waste is one of the major issues, major problems that we have in the world today, both when it comes to climate emissions, but also when it comes to health hazards and emissions to ground and soil. And this is pictures from Europe, from all over the world, where you can see that people are living in the waste, they're living off the waste, and this is how it looks, most parts of the world. So we've come quite far here in Scandinavia and in Northern Europe when it comes to treating waste in a sustainable way. But we want to show the next step and to go forward to reduce the climate emissions even more. We know that landfills are the worst way to treat this residual waste, but it's the main solution all over the world. So just the transformation from landfills to waste to energy reduces emissions sustainably. But then we also need to take care of the last part of emissions from waste incineration, and that we have to do with carbon capture. So just by moving waste from landfills to waste incineration, we actually remove 75% of the climate emissions. And that's, of course, the most important step that we have to do in the rest of the world, both in Asia, Africa, and also mainly in the United States and parts of Europe. Landfills is the main solution for waste. And then when we add carbon capture, we manage to take care of the last 25% of the emissions. And those 25%, of course, are 50% biological, which means that it has an even greater impact for the climate. So that's an important demonstration case also with this project, is that we can demonstrate the bio CCS part and also the possibility to capture and handle CO2 from emission sources that are not situated at port. This is a table of how waste handling looks like, mostly in Europe. The red parts are landfills, the yellow ones are waste to energy or waste incineration, and the green one is recycling. And we know that the green numbers are hugely, they're not based on reality. because we usually, in Europe, we have traditionally been measuring the amount of recycling as the waste sent off to recycling, not the waste actually being recycled. And we know that quite a lot of that waste is rejected and sent back, either to landfills or to waste incineration. So those numbers are not correct, and that's why the EU is changing the way of measuring this now. So we now have to start measuring the waste actually being recycled. So these numbers will go down. So if we hope and plan that we will be moving towards North European standards and the North European way of treating waste, we can hope that in maybe 10 or 15 or 20 years, we will manage to reach 40% recycling percentage and 10% landfills, which will be a huge step forward. And then we still leave about 50% of the waste amounts for waste incineration, which if we should believe the World Bank and that we will double the amounts of waste by 2030, we're talking about 2 billion tons of waste. So it's just huge amounts, increasing with increased welfare, increased populations. And we need to handle it in a much, much better way than we do today. And of course, it costs a lot of money. And that's of course the main issue where we're talking about carbon capture. Where's the business model? There's no business model there. This is a climate measure for now. And we need volume. We need a lot of plants to achieve the learning and the technology development to actually cut the costs in the same way that we have seen with sun power, with wind power, with batteries and so on. But in order to reach that volume, we need start help. So for now, the government is chipping in a large part in this project, and we will also have to look for EU funding for the next European projects to come. Waiting for the ETS prices to go up and the technology prices to go down. And we're hoping to be the first project in a chain of many projects in our waste-to-energy business. And we see that the interest has increased immensely over the last year. And there's really a lot of movement in the business now. People are realizing that this is going to come. This is the next step in the cleaning of flue gas, and we need to be a part of it. So that's good news for us. So, to conclude, we know that CO2 storage is safe. It's very effective as a climate measure. We do it today. Equinor stores about 1 million tons of CO2 every year, has done it for about 20 years. So we know it works, and we know it's possible. We also know that we need to capture biological CO2 in order to reach the 1.5 degree target. And for that, waste will be an important factor in that picture. CO2 capture on waste industry may also be an important part of the city sustainable solutions in order to cut the city's emissions, because waste handling is usually a part of the city's infrastructure and services. Yeah, I think I'm practically through. And we also know that we need to capture 6 billion tons of CO2 before 2050. So we need to get started, and that's why we are very eager to get this project going. Thank you.